Let's find out how to determine whether a molecule is polar or nonpolar. Let's find out the polarity of NCl3. So NCl3. Okay, the first step is to determine the valence electrons of the atoms in the molecules. The valence electrons of nitrogen is 5, while that of chlorine is 7. The next step is to draw the Lewis dot structure. Okay, so the central atom is N, and it has 3 chlorine around it. Then connect the other atoms to the central atoms using single bond. Okay, now the number of valence electrons of nitrogen is 5, so we need to add 2 more electrons here to make the total number of valence electrons of nitrogen 5. And for chlorine, the number of valence electrons is 7, so we need to put 6 here. Okay, there. Then another here. Then here. Okay, now let's check it if the atoms follow the octet rule. For nitrogen, 2, 4, 6, 8. So it is good for nitrogen. For chlorine, 2, 4, 6, 8. Okay, 2, 4, 6, 8, 2, 4, 6, 8. So it is good for all the chlorines as well. Okay, so that is the Lewis dot structure of NCl3. The next step is to determine the designation or notation. So here the designation is A, alright, A, or let's use the central atom. Okay, so it's N, and X. Okay, X is the number of bonding pairs, and the number of bonding pairs is 3. So NX3, and the number of lone pair around the central atom is 1. So just 1. So we just write E here. So That is the notation or designation of NCl3. Now we can see that based on the notation, NCl3 has electron geometry of tetrahedral. Okay, so tetrahedral electron geometry. Okay. Electron geometry. Okay. So the electron geometry is tetrahedral. Tetrahedral. Tetra means 4. Tetra head tetrahedral. Okay, tetrahedral, and it looks like this tetrahedral. Tetrahedral. Okay, well, anyway, that's the electron geometry, and but the molecular geometry is okay. Molecular geometry. Molecular geometry. And the molecular geometry is trigonal pyramidal. Okay. Trigonal pyramidal. Okay. Trigonal pyramidal. So means this is the shape trigonal pyramidal. Okay, so the molecular geometry is trigonal pyramidal, and trigonal pyramidal is asymmetrical. So therefore, since it is asymmetrical, meaning the distribution of electrons around the central atom uh, is not balanced, and if it's not balanced, therefore NCl3 is polar. So NCl3 is polar. Okay. So let's have another example. Uh, let's have another example. Let's erase this. Okay, let's have an example that will give us uh, a molecule that is polar, because this first example is nonpolar. Okay. They can't be erased anymore. Alright, that's an example. Okay, uh, okay, let's have CO2 as our example. CO2. Okay, and based on the periodic table, the valence electron of carbon is 4, while the valence electron of oxygen is 6. Okay, 4 and 6. The central atom here is, okay. Now, once we have identified already the number of valence electron, we can now draw the Lewis dot structure. And to draw the Lewis structure of carbon dioxide or CO2, we put the carbon as the central atom and the oxygen atoms as the other atoms around carbon. Now let's connect them with single bond. Right. Now let's add all the other valence electrons of carbon. Again, the valence electron of carbon is just 4. Okay, here are the other 2. Okay, and for oxygen it is 6, so we have to draw. We need to add 5 electrons here to make the total number of valence electrons 6, 2, 4, and 6. Then we do the same for this oxygen atom. Okay, now let's find out if the atoms follow the octet rule. For carbon, 1, 2, 4, 6, 6 only. 6 only for carbon. So it doesn't follow the octet rule. While for oxygen, 2, 4, 6, 7, 7 only. So the oxygen atoms do not follow the octet rule as well. So what do we do? Okay. So what we can do is we can make this electron and this electron form bond, form a bond. Okay. Okay, let's make them form a bond. Okay, and here's the bond that they form. Okay, we do the same for these two electrons here. This one and this one. Okay, we make them a bond. And there you go. Okay, now let us see if the atoms now follow the octet rule. For carbon, 2468, it is already good for carbon. For oxygen, 2468, it's already also good for oxygen. So now, this is the Lewis dot structure of carbon dioxide. Now, let's using Vesper, we can determine the notation or designation of carbon dioxide. So, okay, here's the designation. So, C, X. Okay, we can see that the number of bonding pairs is 2. Okay, so we write there 2. Okay, and there is no lone pairs. So there is no lone pair. So that's it. This is the notation or designation of carbon dioxide. Okay, so with that notation, we can see that okay, carbon for 6 2. Okay, X2 means that CO2 is linear. Okay, CO2 is linear. Okay. Its electron geometry is linear. Its molecular geometry is also linear. Since it is linear, we can say that the molecular geometry of carbon dioxide is balanced, meaning the electrons uh, are distributed equally around the central atom. So if it is balanced, it means that carbon dioxide is nonpolar.